You know that feeling? You just landed, you turn your phone off airplane mode, and you're just waiting. Well, in that split second, a super complex invisible dance is happening. Today, we're going to pull back the curtain on the most important handshake you never see, how your phone actually connects to the network.
Right, let's get into it. We've all stared at that little icon, watching it flip from no service to a full set of bars. It honestly feels like magic, doesn't it? But it's not. It's actually this brilliant, high-speed negotiation. So how in the world does your phone announce itself to a cell tower and get permission to come online? Let's break it down. So, first things first, we've got to understand the core problem here. A phone can't just, start shouting data into the air whenever it feels like it. If every phone did that, the network would be pure, absolute chaos. There have to be rules of engagement.
And this, right here, this shows you exactly why. On the left, you've got total chaos. Phones are just transmitting whenever, and their signals are all crashing into each other at the tower. It's a mess. But on the right, that's order. Every phone's signal arrives in its own perfectly timed little slot. That's the goal. And getting there, well, it presents two pretty big challenges.
Challenge number one is all about timing, or what the engineers call uplink synchronization. See, the cell tower, which, by the way, is technically called an eNodeB, it has no clue if your phone is right underneath it or 2 miles away. And if a phone that's far away doesn't account for that signal travel time, it's going to be late to the party. The network needs a way to tell it, hey, you're way over there, so you need to send your signal a few microseconds earlier than you think.
The second big challenge is about resources. When your phone's just hanging out in your pocket, it's in what's called idle mode. It's listening, sure, but it has no dedicated channel to talk back to the tower. So before it can send anything at all, not even its own name, it has to politely raise its hand and ask the network for a little slice of bandwidth to use. So, how does the network solve both of these problems at the exact same time? It's all thanks to this incredibly elegant 4-step process called RACH. That stands for Random Access Channel. And this is the digital handshake we've been talking about. The best way to think about it is like a very formal, very fast introduction at a party. First, you kind of announce your presence to the room. Then, the host points you out and gives you a specific time and place to talk. After that, you introduce yourself properly, and finally, the host confirms they heard you and officially welcomes you in. Let's walk through how this works, step by step. Step 1 is called the Preamble. Your phone picks one of 64 random, totally anonymous signatures and sends it to the tower. At this point, the tower has no idea who you are, just that someone is knocking on the door. It's basically a simple, anonymous hello. Now for step 2, the tower sends back something called the Random Access Response. And this message is just brilliant. Based on when that preamble arrived, the tower instantly calculates your distance and sends back a timing advance command. That's the instruction to transmit a little earlier. It also gives you a temporary ID and a small grant of resources. It's basically saying, okay, I hear you, use this specific channel at this specific time and tell me who you really are. Okay, step 3. Using those exact resources it was just given, your phone sends its first real message. This is the one that contains its actual network ID and why it wants to connect. Maybe you're making a call or an app needs to sync up. This is the crucial moment. It's the very first time the network knows your phone's unique identity. And finally, step 4, contention resolution. The tower gets your ID and sends a confirmation message right back echoing your ID. As soon as your phone sees its own ID repeated back to it, it knows the handshake was a success. It is officially on the network and can start sending and receiving data. Boom. But wait a second, the full name is Contention-Based Random Access. And that word, contention, that's key. It implies conflict, right? So what happens when things don't go so perfectly? This is the million-dollar question. Remember back in step 1, your phone picks a random signature from a pool of 64? Well, in a crowded place like a concert or an airport, it's totally possible for 2 different phones to pick the exact same one and send it at the exact same time. What happens then? Well, the tower can't tell them apart. It just sees one preamble, so it sends back one set of instructions in step 2. But here's the problem. Both phones get that message and think it's for them. Then in step 3, they both try to send their unique IDs using the exact same radio resources, and bam, their signals collide and become a garbled mess. And this is where the design of the system is just so clever. The tower will probably be able to decode one of the messages through the noise, but not both. So it declares that phone the winner by confirming its ID in step 4. The other phone? It sees a confirmation for an ID that isn't its own and it knows it lost the tie. So it just backs off, waits a random little bit of time, and then starts the whole 4-step handshake all over again. No fuss, no panic. It's a system designed to handle collisions gracefully. So let's put this all together. Let's look at the final blueprint for this incredible, high-speed negotiation that's happening thousands of times a day, probably right there in your pocket.
This table really sums it all up, doesn't it? You see the terms we've been using, UE for your phone and eNB for the tower. Step 1, the preamble, is the phone just saying, I need to talk. Step 2, the response from the tower, is, okay, adjust your timing and use this slot. Step 3 is the phone finally revealing, here's who I really am. And step 4 is the tower saying, got it. User X, you're connected.
And that really is the main takeaway. This entire 4-step dance, including sorting out any collisions along the way, happens in just a few milliseconds. It is an invisible, lightning-fast process that is the absolute foundation of our mobile world, making sure that chaos becomes order every single time you connect. Now, this handshake we just covered, that's all for getting onto the network when you're starting from scratch. But that leaves a really interesting question, right? What happens with a phone that's already connected and is moving, say on a train, and it has to jump from one cell tower to the next? Well, that's a whole different kind of handshake.